Welcome to the Soft Spoken Scientists. Today we'll work through limiting reactant questions exactly the way they appear on general chemistry exams. Each question will be solved step by step with full setup and final answers. Look at this example. Given the reaction 2H2 plus O2 and forms 2H2O. We see it in this box. Okay? So, and they say if 5 moles of H2 reacts with 2 moles of oxygen, which reactant is the limiting reactant? So here's what you do. First, you look at the equation they give you, given the reaction right here, and you see if it's balanced on both sides. And when I say that, I mean, are there the same number of elements on both sides? I have 1 hydrogen here, right, on the left side. And then check this out though. I have I have 2 hydrogens, and I have another 2 hydrogens here. So 2 hydrogens from that plus times this 2, that would be 4. I have 4 hydrogens. And then I have 2 oxygens. So 2 oxygens. Now here, this 2 is being multiplied to this 2 here. 2 times 2 is 4, so I have 4 hydrogens here. This 2 is going to be multiplied to this oxygen. So I have 2 oxygens. That looks balanced to me, right? All right. So the first step we're going to do is predict product from H2. If 5 moles of H2, right? So we have 5 moles of H2. And we also look at this and we see, okay, we have 2 moles of H2. And we're trying to get to moles of water. When you're trying to get to limiting reactant, you got to look at the product. We're trying to get to moles of water. We have 2 moles of water. What is 5 times 2? 10. What is 10 divided by 2? 5. So 5.00 moles of H2O. Notice how my units cancel out, and then I'm in the correct units, so I know I got my correct answer. Now let's look at the next part, because that was only the first part. This is part of the answer we were looking for. That was step 1. Let's do step 2 now, because we have to deal with 2 moles of O2. We have 2.00 moles of O2. I'm going to look at this and say, okay, I have 1 mole of O2 in blue. I wrote the 1. There is an invisible 1. So 1 mole of O2 for every 2 moles of water. And the moles of oxygen cancel out. What is 2 times 2? 4. So 4.00 moles of H2O. So I got my products from H2 and from O2. I got those 2 right there, but I'm not done. So I need to compare them. So with H2, you guys saw I had 5.00 moles of water. And with moles of O2, I had 4.00 moles of H2O. So by looking at this, I can tell you guys 4 is less than 5, and I'm sure you guys would agree with me on that. So O2 is the limiting reactant. It produces less product. All right? The limiting reactant is the one that makes the least amount of product. I can't stress that enough. Okay, let's move on to question 2. So, given the reaction up here, if 14 grams of N2 reacts with 3 grams of H2, which reactant is limiting? Let's take a look here, right? So now we're given grams. This is a bit different, but we already know we need our moles, and we're going to get to it, so don't worry. First, let me make sure the equation is balanced. I have 2, put an invisible line right here, or a dot, dot, dot line. I have 2 moles of N. I have 6 moles of H. 2 times 3 is 6. I have 2 moles of N. So okay. And then 2 times the 3, H3, so that's 6 H's. So that's balanced to me. You know what I mean? Like, I don't need to try to balance it because it's already balanced. Okay. So let's start with the nitrogen. So we have 14.0 grams of N2. It's reacting with it's reacting with grams of nitrogen. And you'll look at your periodic table and you'll know this, each nitrogen has 14 grams. So N2 is 14 plus 14, which is 28, okay? So I have 28.0 grams of N2 for every 1 mole of N2, all right? So the grams of N2 cancels out, and then I'm left with 0.500 moles of N2, all right? Now, let's look at, so 1 mole of N2 is just saying like you have one, kind of like one big apple, and if you split it into, and each one is, and 1 mole of N2 is having 2 parts of it that are making up the apple, like one half of the apple, the other half of the apple. That's 28 grams. Think of it that way, if that made sense. All right, and I convert it into moles, which is what I wanted, but we're gonna have to convert later into a different kind of mole, and you'll see what I'm talking about. So, the next one we have 3.00 grams of H2. We know from the periodic table that one hydrogen is 1 gram, 1.01 grams. To be technical, is 1.01 grams. So if I have 2 grams of H2, grams of H2, that would represent 2.02 grams of H2 for every 1 mole of H2, right? So if you look, I didn't use the balanced equation yet. That's later, okay? These 1 mole of H2, 1 mole of N2, that came from me knowing that, you know, 1 mole of N2 is just the amount of grams, 1 mole of H2 is the amount of grams of H2. What is 3 times 1, you guys? 3. What's 3 divided by 2.02? 1.49 moles of H2. So, I cancel out the grams of H2. These are what I'm left with, okay? Now, I need to predict the product from N2. So, I'm going to put moles of N2 here, and I'm trying to get to moles of NH3. So I'm looking at this. I have 1 mole of N2 and then 2 moles of NH3. I'm going to cancel out the moles of N2, and I have 1.00, that's 3 sig figs, moles of NH3. Now, I'm going to do the same thing. Moles of H2 needs to be in the denominator, and I would have, look at the balanced equation, you guys, moles of H2 is 3. And I'm trying to get to moles of NH3. Whoop, I'm gonna make that a little longer. And I have a 2 right here. What's 1.49 times 2/3? 0.993 moles of NH3. So now I'm going to compare them. I'm looking at the moles, and I see H2 has a smaller amount of moles of NH3. We got to the product. We converted it to get the moles of the product. 0.993 is less than 1.0. So guess what? You know what that means? Even if the values are close, the smaller product decides. So H2, is your limiting reactant. Good job. Let's try this one. Question 3. How many grams of NH3 are produced using question 2? Okay. This is question 3. Okay. But looking back at the old one, we know that the limiting reactant was what? H2 equals limiting reactant. And the predicted NH3 is 0.993 moles. All right. So, how many grams of NH3 are produced? So let's just pick up where we left off, you guys. 0.993 moles of NH3. Well, I know that N is about 14 grams, and then every H is 1.01 grams. So what's 14 plus 3 H's? 17.03. So I'm going to keep that in mind. I have 1 mole of NH3. For every 1 mole of NH3, I have 17.03 grams of NH3. And when I multiply the numerators, I'm going to get 16.9 grams of NH3. And guess what? I got rid of the moles of NH3. I gave the problem what they wanted. Just watch those units and I promise you'll get to the right answer. Final product amounts always come from the limiting reactant. Okay, number 4. If one reactant remains after the reaction is complete, what's it called? So it's not, we have a lot left. It's remaining, it's still there. That means you have more of it. The excess reactant is the reactant that is left over after the limiting reactant gets used up. And that's about it, you know. Limiting reactant rule. Calculate product from each reactant. The one that makes less product is limiting. Okay, limiting reactant questions follow the same pattern every time. Practice identifying the limiting reactant and the rest of the problem becomes straightforward. Thank you guys so much for tuning in. Please like and subscribe if this video has helped you. And please remember, STEM is for everybody, especially you.